Hello everybody, welcome to another Henstitute Help. I'm using a different program, so that's why you don't see me. These are like my normal, the, the voice from above or the voice from beyond explaining problems. So I grabbed number 3 and 4, put them together. The key idea here is I'm going to try to set them up so you can kind of solve them. These are mostly dealing with the concept of density. So, like I mentioned before, density's equation looks like this. So density is represented by the Greek letter rho. Kind of looks like a P. I always make it almost look like a giant E, and it's equal to the mass of an object divided by its volume. Now in both of these, we also have to kind of take into account how do we find volumes of different things. For example, this waterbed, they give the dimensions here as these 3 different values, so we should be able to remember that volume is length, width, and height. So we just have to multiply those. In number 4, it's a cylindrical storage tank. Now I figure you can look up these things, but I'm going to go ahead and throw this out there. I didn't put it on the document, but it's things that we probably want to eventually add to our equation sheet, that type of thing. But the volume of a cylinder is actually the area of a circle, so pi r squared, and then multiplied by the height. Because the idea is you have this circle here and then the height of a cylinder. So you're finding the area of this shape and then multiplying by the length of the thing to actually get the full volume. So that's a key one for this one, so that we can actually kind of figure some of this stuff out. So in both of these cases, we're going to have to find the volumes of these objects. So in number 3, we can actually calculate the volume, just multiply those 3 things together and get the total volume. The floor of the bedroom will tolerate an additional weight of no more than 6,660 newtons. Find the weight of the water in the bed and determine whether the bed should be purchased. So the idea of this one, we also have to remember one other thing. The force of gravity, or the weight of an object, is going to be equal to its mass times gravity. But here's a cool thing. If I take this equation and rearrange it and solve it for mass, mass is going to be density times volume. So another way of actually finding things, if you have the density of an object and the volume of an object, multiplying those 2 together gives you the mass, and then you can multiply by gravity. We're going to see this later when we do some more Archimedes principle problems, because that's how we relate it to the buoyant force, that type of thing. So on this one, the way I would kind of do this, we know the density of water. So they gave us the density of water up here, and it's a water bed. We know the volume now, because we've calculated these 3. We just have to multiply them together. And then we know gravity. Gravity is still, for us, going to be our normal 9.8 meters per second squared. So we got some information that we have to kind of go back and remember. So we're going to end up using this version to solve this one and then calculate what we get. So once we figure that out, that'll be the weight of the water in the bed, or basically the weight of the water bed, and then determine whether it should be purchased. Is it larger or smaller than 6,660 newtons? Okay. In number 4, our cylindrical storage tank, we have the radius and we have the height. So we can use those to find the volume again. So we're going to find our volume. This time we also have the mass of our solvent. Okay, so we're just trying to find the density of this. So we're just using this lovely equation here. Switch out colors. So the density of the solvent should just be the mass divided by the volume. This is our mass. And then when we use the equation here, this will allow us to find the volume that we can put in there. So we put those 2 things in, we get a density. Now, the interesting thing about density, and you can see it up here in our 2 little things that we talk about, the unit is a kilogram, mass unit, over a volume unit. The way we're going to put volumes is in cubic meters. Okay? When you did this probably in a chemistry class, you probably did grams per cubic centimeter. So we want to kind of get away from that, because we want it in kilograms, because that's our base unit of mass in physics, and the meter, or the cubic meter, is our base unit of that. One thing to kind of realize, that it takes 1,000 grams per cubic centimeter to make 1 kilogram per cubic meter. So that's the idea of actually kind of doing a little bit of conversion here so we can kind of figure some stuff out. But that's not really important. As long as you are putting it into the right units, you should be perfectly fine. Okay, hope this helps. Oh, I realized I need to make an extension because I made a mistake with what I was just writing, and I didn't mean to. It's actually the reverse. So if we do a conversion, if you say, so water we always thought of as 1 gram per cubic centimeter, okay? That was the way people always learned it. We know that there are 1,000 grams in a kilogram. So that's an easy conversion. We can convert. The hard one is centimeters. Most people go, oh yeah, there's 100 centimeters in 1 meter. But this is actually cubic centimeters. So what we have to do is we have to cube both of these to get that to happen. So what that gives you is that's 100 cubed. So that's 1 with 1, 2, 3, 4, 5, 6. So it's a million. There are a million cubic centimeters in a cubic meter. The 1,000 down here will cancel out 1,000 there. So actually what I meant was in 1 cubic centimeter, there are, I'll say that again because I think I got cut off. In 1 cubic centimeter, there are 1,000 cubic kilograms per cubic meter. So 1 gram per cubic centimeter is 1,000 kilograms per cubic meter. Hope that helps.